Hello. I'm going to review a little bit of what we talked about when we were opening up RobotC. There's a lot of information to cover and remember, so I'm going to go through the very basics of starting up RobotC on our computers. Remember, there are two user interfaces on your desktop. You always want to use a RobotC 4.0. The other one is a graphical user interface. It's kind of like a click and play. We use the RobotC 4.0, which is still user-friendly, but it is more detailed. Okay, the first thing that comes up is your startup screen. Let's see, I can move this screen, there we go. Okay, the natural language is what we want to use, and how to get to this, if you don't have it or can't see it, is under Robot, under Platform Type. You need to make sure this says Natural Language PLTW. If you haven't done this, you're going to first have to pick VEX 2.0 or Cortex, which is around this area, and then go into it again. Then you will see the Natural Language PLTW. The other change you have to make is the communication mode. You need to make sure it says USB only. That's important for when you go to use your like your dragsters and you need to use the while loop, and you need it to run independently. So other than that, we covered that under natural language, you need your movement, start motor and stop motor. These are ones you'll use every time. Under the wait, you'll use the wait time. And under until, you'll use here until touch for your bump and your limit switch. You will use potentiometer greater than or less than, and then until dark or until light. Other than that, when you start a new file, the first thing that's going to come up is your task main. Now remember, you do not change this, don't move it, don't delete it. Those always have to be there. Underneath the task main, you'll see the curly brackets. In between the curly brackets are where your code has to go. So if you start writing down here on line 8, for say, your computer is not going to see it. So you need to make sure you're in between the curly brackets at all time. Before you start your program, you need to tell your program where you have things plugged into in your Cortex. So you go to Motors and Sensor Setup. When you click on here, you're going to see that motors, you can write in ports, like you could go, your right motor is in port 2, which is probably where it is right now. You would change this to this. You have a 3-wire motor, and you could write right or left motor right here. No space, and remember the second word is always capitalized. You would change this to a 3-wire. And then you could go to your analog sensors. The sensors that we have are for analog are the potentiometer and the line follower. Under the digital sensors, we use the touch sensor and the VEX LED. Now, because we have this arrangement with VEX and PLTW, they have together developed for us the GTT testbed setup. So this is exactly what you have minus the Clawbot. Hit apply, hit OK, and you can see your pragma gets entered right here. So now when I go to Motors and Sensor Setup, I can see they have already put in all of my sensors and my motors, which is great. So I'm going to leave that alone. Now, to write a basic program to start a motor and to stop it, what you need to do is go back over here to Natural Language. Under Movement, let's say you want to start a motor. You're going to drag it. You can click and drag. And you can be anywhere underneath here. You don't have to be exactly on line 6. These, if I hit enter, 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 you have all this white space here. Remember, your computer does not read white space. It only reads the words. But if you see a black space or black print, which we pulled over here under Start Motor, right here, motor port, they're saying where is your motor plugged into. So if you just double click, it'll highlight for you, and you can type in right motor, and then click in the speed, which full speed is 127. Now you can also, instead of doing right motor, and you'll notice that it didn't turn black yet, it will when you compile. Or you could write in port 2, and that will automatically pick up, and you can see it was trying to print it as it goes. Then hit enter. you're going to want to stop or hold this for 2 seconds or however long we tell you. If you want it for 2 seconds, you just type in the letter or the number 2, hit enter, and then you want to stop this motor. Now technically it would stop after 2, but you always want to close it up. And you want to type the same thing because you want this same motor to stop after it runs for 2 seconds. Now when you compile, this will tell you that, okay, you've got a good working program if you ran it. You always want to make sure you save it in documents. Right now I'm not going to save this, so I'm going to say cancel. And you can see that this compiled and it gives the exact date and time. Now if for some reason you had something, if you forgot to leave a semicolon, when you go to compile program, you're going to get an error message. And again, I'm going to cancel here because I don't need to say it. And what you need to do is look at what line number it says right here, because it's saying at line number 7, there's a missing semicolon. It will always kind of tell you what's going on and what they think you meant to do or what you have missed. So if I enter that semicolon right now and I compile again, save it or not, it will now tell me that, okay, I've got a good program and this is ready to run. And that pretty much takes you through writing a very basic program. When you are done, go ahead and save this one particularly as your My First program. And go ahead and hook up to your test bed and see if this will work.